Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in this session I'm discussing the regression output related to MLRM. In our previous session, if you remember, we discussed in greater detail the concept of SLRM, right? And simply you have learned that the SLRM is a model where we have only one independent variable. It stands for single linear regression model, a model with one independent variables or regressor. So today we are talking about MLRM. So MLRM is a model where we have many independent variables. It stands for multiple linear regression model. So this is the example of MLRM. This is indeed a model which is called MLRM. Why? Because we have many independent variables such as x1, x2, x3, and up to xki. So dear students, in our situations today, I have just example related to Afghanistan. The dependent variable I've collected from the World Bank, right? That is the GDP per capita. And we have three independent variables, which are grants, FDA, and agriculture. And I'm just interested to know how these three independent variables affect GDP per capita in Afghanistan. So for this purpose, dear students, first we should have the regression output. And for this, click on the data and then click on the data analysis and click on the regression, right? So the dependent variable in our analysis, which is y, that is GDP per capita. Just choose this, right, in a range. And then the independent variables, we have a group of independent variables, right? And just try to know how these three independent variables affect our dependent variables, right? We are dealing in multiple linear regression analysis, dear students. Simply click here. Okay, just choose the labels. And for confidence level, if you are interested to reject your null hypothesis under the significance level of 0.05, then you should choose 95% confidence interval, right? Okay, choose the output range. Okay, yes, here I just need the output. And this is output result. So the most important pieces of information first, what I just want to explain that related to regression statistic. The first table. In the first value, dear student, that is multiple R. Okay, what does this value multiple R indicate? Simply, if you remember, we have explained the concept of correlation. So the multiple R, that's indeed the correlation of two values, correlation between the predicted values of y and unpredicted values of y. You can see the actual values of y and the predicted values of y. So in our example here, we already have the actual values. This is actual value of our dependent variable. This is our y. And what is the predicted value of y? So first you should know what are the predicted values. So the predicted values, they are just computed based on this model. Okay. Okay, if you just try to find out this y, we are just predicting this y. So for predictions, you should have beta naught and beta 1 and beta 2 and all these values we have in our output here. Simply, this is intercept and this is our grant. This is the beta naught, and this is the coefficient of grant, which is beta 1. This is the coefficient of FDA, which is beta 2, and this is the coefficient of the agriculture, which is beta 3. Simply. So if you just try to find out our predicted value, we are using y hat. Simply predicted values. Just use this function. So first we have beta naught equal sign. Just take the beta naught from here. This is our intercept or beta naught. Okay, just press F4, stick to this reference cell, and then plus. Next, just go exactly according to this equation. Okay, and after plus, look, we have beta 1. And where is beta 1? Okay, beta 1 is, that is just the coefficient of x1. So x1 in our example, that is grants. So the coefficient of grants, that this is the coefficient of grant, right? Simply click on this value, right? And press F4, right? Because we just stick to this reference cell. And then the beta 1 should be multiplied by x. So you should multiply with the x value. And the x here is the grants value, right? And then, dear students, next, in this manner, you should continue. Then we have beta 2, and the beta 2 value here is FDI. This is beta 2, press F4, and this should be multiplied with the x value of FDI. This is x of FDI, right? And then plus, dear students, in the next we have the third variable, which is x3, right? And that is, dear students, simply agriculture. Click on the agriculture, press F4, and then that should be multiplied by the value of agriculture. Here we have the value of agriculture. Just click here and just press the right arrow to move into agriculture, right? Now, very easy to student. Look here, we have beta naught. So the first value, this is beta naught, and then you should plus the second is the beta 1 coefficient, right? Should be multiplied by the x value, which is ground, and the beta 2 coefficient should be multiplied by its x, which is FDI. And the beta 3 coefficient, right, we have just taken from there, should be multiplied by the value x value, which is agriculture. Just press into this one. This is the predicted values. So, dear students, this multiple linear regression model predicted these values for us. So these are actual value, right? We're just checking how the model is just predicting, right? So the actual value, so you can see the prediction is 166, right? And here the actual is 198 and the prediction is 184. So what is the residual return? The difference between the actual value and the predicted value, that's residual. Okay, now we are just coming to our point here. That is multiple R. Multiple R is just checking whether the actual Y, this is actual Y, which is GDP per capita, and predicted Y, this is predictive, whether they are related or not. And what is their correlation value? Simply, we have the function of correlation. If you remember, we have already discussed, right? So for correlation equal sign, just write correl, right? And then just take your first variable, which is the GDP per capita, which is the actual value, and the second is the prediction or the predicted value distance. Okay, simply this is just giving me the value of 0.91, which is just close into this value. Here's what is the interpretation. You have already learned that the correlation is just having the limit of +1 and -1, right? So if the correlation is just getting closer to +1, we say there is a strong positive correlation. It means these two variables, they are strongly correlated. So we can say the y-hat, the predicted y-hat, and the actual values, there is a strong relationship between them. And if it is just closing to -1, we say there is a negative strong correlation. And if it is just getting closer to 0, we can say there is no correlation. But this one is just closer to +1, we say there is a positive correlation between GDP and y-hat, which is our predicted value. Okay, the concept I have already given you students in the MLRM, if you remember, right? So if the predicted values and the actual values, they are correlated, so this is just giving a meaning that the model is a fitted model. Why? Because the line is just around the actual value. Okay, I'm just giving you the concept which I've already explained in the single linear regression model, but just for the purpose of understanding, once again I'm just repeating this. This is, dear student, this is the x axis simply, and this is the y, right? Okay, now this is the slope. Okay, dear students, this is the slope. Now if I'm just plotting the actual points, right, and you just can see these are the actual points, this is the actual points. Now the actual points, dear students, if you can just see, they are just deviated from the regression line, right? So you just can see, you can just guess from here. Okay, this is just a hypothetical graph. This is not based on the data. Okay, now you can just guess here how closely the predicted values, they are just related to our actual values. So if they are correlated, then the actual and predicted value, they are just closer together. The actual values, they are just clustered around the central regression line. So here you can just see that they are somehow related. The same idea and concept that is just given by the multiple R students. If the multiple R value is just getting closer to +1, then you can guess that there is just a positive relationship, dear students. In the actual, in the predicted value, they are just closer. And we have practically found, this is just the column for the actual value and this predicted value. We found out the correlation is 0.915, dear students. Okay, hopefully this concept is clear. Now the second value, dear students, this is R square. Okay, what is meant by R square? Okay, dear students, if you remember, we have already in many times explained the concept of sum of square, the total sum of square, and the sum of square regression and total sum of square, right? So once again, just very quickly, I'm just repeating here, okay? Look, okay, this is just, okay, I'm just repeating that concept once more. Okay, dear students, this is the slope. Okay, I'm sorry for drawing, for my drawing. Okay, now assume this is the average value we have. This is the average line, dear students. Okay, now I'm just plotting the point here. You can say this point, this is 1 point and 1 point we have here, right? And 1 point we have here, dear students, right? So you can say, dear students, very simply, this is the difference. Here we have y, this is y actual, right? And this is, dear student, and exactly in this line, this is y hat. Can you see? So y hat. Okay, this is, dear student, this is y bar. This is simply y. This is the average value of y. So the differences we have, this difference, dear students, this is from this point up to this point, dear students. This is the sum of square error. And this differentiation is called sum of square regression. And the total variation, simply, for example, this is the total variation from this point up to this point. This is the total variation. This is called TSS, right? So you can say simply to the students, okay, this is the sum of square. Okay, I just write here. This one is, you can say, dear students, this is the sum of square error. This is the error. This is the area which is not predicted, simply, right? Okay, and this is, dear students, this is the area. This is the area, dear students, which you can say this is the sum of square regression, simply, right? In the total area, this is, okay, this one in gray line, right? This is, you're saying, this one, you can say this is TSS. This is total sum of square. Now, in mathematics, simply I'm just asking, if this is the total area, this is the explained area, and this is unexplained area. So what is the proportion of explained area? What is the percentage of the explained area? So the SSR should be divided by the TSS, right? Simply that is just giving you the R square value. And this is also called the coefficient of determination, dear students, okay? Once again, I'm just repeating, dear students. The SSR value in our output here, this is the SSR regression. You can say this is the value, this is the sum of square regression, the sum of square regression, this value regression, and this is SS, right? And this is the sum of square, which is error, right? Residual means error. So this is the sum of square error, this is sum of square regression, and this is the total sum of square. So when you just divide the sum of square regression on the total sum of square, right? When you just divide, that is just giving you the coefficient of determination, which is R square. And what is the interpretation? You can say this is the total variation explained by independent variables we have in our model, okay? Once again, what is the formula for R square? Simply the R square, you can say R square that equals to the sum of square error should be divided by PS, the total sum of square. Or sometimes you may find out the formula of R squared like this. We have the R squared that equals to 1 minus the sum of square error should be divided by total sum of square. And the answer is same, dear students. Okay, here just the unexplained area is just subtracted from 1, and here we directly find out the unexplained area. So dear students, what is the interpretation of the coefficient of determinations, which is R square? You can say 83% changes in y, that is just explained by these three independent variables combinedly. Very clear. So you can say how much total variations explained by these three independent variables. You can say 83.85%, and it's almost 17% variations in our y dependent variables we have, that is due to other factors. So you can say 83.86% variations or changes in GDP that happens due to these three independent variables, and the rest, you can say 17%, which happens, which is not captured by the model. You can say that is changes, or that is just variations not explained by the model, and that are just due to other factors, students. Okay, so that changes is due to other factors. Hopefully the concept of R square is clear. Okay, next we have the concept of adjusted R square, students. Okay, dear students, adjusted R square simply, right? That shows how well your model explain the data after adjusting for a number of variables. Okay, if you just try to incorporate new variables into your model, right? Then the adjusted R square is just giving you another R square model that is just adjusted for no variable. Okay, what do we mean by this? Okay, currently we have three variables. If you incorporate new independent variable into the set of total variables, right, then just the adjusted R square is just checking whether the new variable incorporated is having relevancy in the model or not, whether that is just significantly affecting the R square or not. In simple words, sometimes we have independent variable in our total sum of variables. In the set of variables, we may have independent variable that is not relevant in our analysis, that may not significantly or sufficiently affecting our R square, right? So we can say that model is just making our model complex and that is not relevant in our analysis. So for that purpose, the adjusted R square just drop, right? When you have just observed the differences between the R square and adjusted R square, it means the adjusted R square is just significantly lower than R square. For example, the R square is 0.83 and the adjusted square R square is 0.58, for example. Look, 0.58 and 0.83, there is a significant difference. You can say the model is overfitted. This is what is called a model is overfitted situations. Okay, so when we call the model is overfitted, when the difference between the R square and adjusted R square is really high, and that is just indicating that we may have one or more independent variables in our set of variables that they are not relevant, right? For example, I'm just incorporating a new variable by the name of sleeping R of an individual. Okay, if I'm just incorporating a sleeping R, it's really indeed not relevant for our analysis here. And this sleeping R new variable may not significantly affect our R square, right? Our dependent variable. So that's why it's just making our model complex. And this irrelevancy is just checked by the adjusted R square. So if you just check that the adjusted R square is down because of the incorporation of new variables, then you can say the model is now overfitted. And here's when this adjusted R square value is used most of the time when we are comparing many independent variables, sorry, many models, many MLRM, or many models with many independent variables, just to check which model is fitted model. So once again, if you just observe the differences between these two variables, right, R square and adjusted R square, then you can claim the model is overfitted. Overfitted means a model has some variables which are not really relevant for our analysis. Okay. Okay. Now I'm just practically showing you how this adjusted R square function is working. Look, dear students. This is, dear student, this is the formula of adjusted R square. Okay. Once again, I'm just repeating. I have already explained, and I'm just explaining again, that if we are incorporating new variables, so the k here in this k is just indicating the number of independent variables. So we have three independent variables. Now, if you incorporate new variables into the model here, for example, we have x1, x2, x3, and just you increase one x4, right, and just make four independent variables. So now this fourth variable, just we are just checking whether the new variable is useful or not, right? If the new variable is useful, then the R square increase significantly, or you can say sufficiently. So if the new variable is not useful, then the R square does not increase sufficiently or significantly, and instead the adjusted R square, sorry here, instead the adjusted R square you find out that is what? That is smaller. Once again, if you increase a new independent variable, just if it is useful, the adjusted R square increases. If it is not useful, the adjusted R square value decreases. Look, dear students, here. Our claim is that if you incorporate new independent variable, that must have some positive effect, right? That must have some effect on our GDP per capita. Or when the GDP per capita is affected, it means the R square increases, the total variation increases because of the new variable. So in this model, look, dear, so the function is from 1 we minus this value, right? So in the numerator we have R square. If you increase new independent variables, so that is the k, that is just reducing the degree of freedom, the denominator. This is the degree of freedom. Okay, when you increase the k, right, that is subtracted from n, so you will have a smaller denominator, right? If this k is sufficiently increasing the r square, and the r square is just minus from 1, and this is just scaled up by the number of degree of freedom, it's mean when the r square value is higher, then you can say the numerator will become smaller. The proportional decrease in the numerator is higher than the proportional decrease in the denominator. So when you have a smaller numerator and that is divided by a bigger and larger denominator, that is just giving you a value which is smaller, and when the smaller value is subtracted from 1, that is just giving you the higher adjusted r square. And that is the situation when the new incorporation, the new addition of the variable, that is just significant. It means that is just sufficiently enough, that is just increasing our r square sufficiently, dear students. Or you can say the variation because of that new variable is enough in the model, dear students. Okay, I'm just concluding, dear students. Okay, the concept behind the adjusted r square is, if we have model, in this model we have many independent variables, just compare the r square with the adjusted r square. If adjusted r square is closer to r square, you can still claim the model is fitted and there is no problem. But if there is difference between these two values, then you can say in model we have some independent variables, dear students, which are not relevant for our analysis. Or you can say there is a model which is not indeed affecting our dependent variables, or if it does affect our dependent variable, the value of variations or the changes in dependent variable, that is so insignificant and small, so we can say that that is irrelevant. And that is the situations where we call our model the overfitted model. So in our example here, dear students, a model is not overfitted. Hopefully the concept of the adjusted r square is also clear. Now we are just discussing the standard error, dear students. Okay, dear students, we have two types of standard error in the regression output. One is this standard error, which is in regression statistic, and one standard error we have which is closer here to the coefficients. Okay, you can say this is the standard error of the coefficient, and this is the standard error of the residuals, as this is the standard error of estimate. Okay, these two standard errors are different. The concept behind is different, dear students. Okay, this is the standard error of estimates are residual, and this is the standard error of coefficient. Okay, I'm just first explaining what is the standard error of the residual. Okay, dear students, I'm again and again talking about residuals and error, that is same. Okay, both of them, these terms are same, residual error. Okay, and now I'm just explaining what is the standard error. So once again, this can be only helpful through graphs. Okay, I'm just drawing a graph here. Look, dear students, this is our y-axis here simply, and this is our x-axis, right? This is x-axis, and this is y-axis, dear students. Okay, now what is standard error? If I just draw a slope here, right? Now, and just give you the points, right? The actual points. So this is the actual point, dear students. Look, and here we have actual points. And this is actual points, and these are the actual points. You can see. Okay. Now, if you just observe closely, dear student, the actual points, this is actually the deviations you can have, right? The residual, you can say. So we have somewhere we have more deviations, and somewhere we have less deviations, right? Here we have less deviations, and here we have more deviations. Now I'm just asking a question. This is the error. Okay, what is the average distance of the error from this regression line? Okay, so this is some have more, and this is less, and this is also. So what is the average variations of the error around this regression line? So you can say the standard deviations of the error around this line, simply, dear student, that is the standard error. Okay, simply. So when you just try to know what is the average distance here, right? The up and down we have here, that is just different. The deviation, somewhere we have high deviations, fluctuations, somewhere we have low. What is the average fluctuations of error around this regression line, dear students? So this is just shown by standard error. We can also call it the standard error of the estimates, or the standard error of the residual, dear students. If you just try to find out this practically, have to find out the standard error of the residual. Okay, Now you should know what is the formula. The concept is clear. I'm just practically showing you have to find out the standard error of the residual. Okay, this is a formula, dear students. Simply, okay, I'm just using this. Okay, so just take the sum of uh, y, right? Y minus y hat, right? Simply, and just square it and you sum it, and this should be divided by, dear students, n minus 1 minus k, right? Simply, and just take the square root. Okay, this is just giving you the standard error of the estimates. Right? Simply, this is the standard error of what? The estimate at the standard error of residual. What is the standard fluctuations around this regression line? Okay, for this, dear students, have to do it practically. Okay, dear students, look, we just find out all these values we have in this formula. Y minus y hat, this is residual. So for finding out residual, we first increase one more column, and this is, you can say, error residual simply. So from the actual value, when you subtract the y hat which is predicted, this is just giving you the residual, right? And then the residual should be squared. Okay, simply the residual value should be square, so equal sign, this value should be multiplied by itself simply. Okay, drag it down, dear students, and this is the value. Simply, this is the total sum of square, you can say sum of square sorry, sum of square error, right? Sum of square error, this is sum of square error, dear students, in the numerator, right? And just when you edit, this is the total. Now this sum of square error which is in the numerator should be divided by n minus 1 minus k. Okay, n is simply 20, dear students, minus 1 minus k is 3, and the answer is just 16. This is 16, dear students. Now you should divide this value by the n minus 1 minus k, and this is, dear students, a value you should take the square root of. So this standard error, when you find out, just take the square root of this value, right? Simply, this is the square root, and now this is giving you the answer, and this is 67.45, and this is answer same. Okay, this is error, dear students. You can say the standard error by average the fluctuation are the standard, or you can say the average fluctuations around the regression line, that is, dear students, you can say 67.45. Some have this value is not really good. Why? Because it's high. Okay, if we just observe the trend which is observed here by r square, so it's really good from here, 83.85% relationship because of the independent variables. But when we just observe the distance, the average distance of the error around this regression line is somehow high, that is 67.45 students. Okay, hopefully these four values are clear, students. All right,